function has an odd or even degree, and then you have to explain how you know. So for A, we know it's even because the ends go in the same direction, and it's negative because the graph falls on the right for the leading coefficient. For B, it's an odd degree because the ends are going in opposite directions, and the leading coefficient is positive because the right side rises. I said rises up. So something you might want to write on your note card is that the rule is if the degree is odd, they go the opposite direction. If it's even, they go the same direction, the ends. And then the leading coefficient tells you if it's positive, it goes up on the right, and if it's negative, it goes down on the right. So remember, it's always about that right side. That's what it's going to tell you, okay, about the graph. Okay, so that's your number 1. For number 2, this is a multiple choice question, because remember, you are going to have multiple choice on your test tomorrow. So it says, if the end behavior of a polynomial f of x is as x goes to negative infinity, and look what I do these annotations. So I know what this means. As x goes to negative infinity means the left. F of x goes to negative infinity means down. So on the left side it goes down, on the right side it goes up. Well, we know that the right side tells us about the positive coefficient, or the leading coefficient, whether it's positive or negative. But because it's going up, that means that it's a positive LCO, okay, a positive leading coefficient. Okay, so what I did is I looked at the leading coefficient. This was negative, so A is out. For B, 4 is positive, so that's in. Negative 2, nope, that one has to go. And then positive 2 there, so that was good. Now the next thing I'm going to do is pay attention to which direction the ends are going. So this goes down and this goes up. So the ends are going in opposite directions. So if they're going in opposite directions, the degree is odd. So 4x to the third, yep. 3 is odd. 5 is odd, so that one also works. So your answer should be E, both B and D. Questions for me on that one? So using the process of elimination there. For number 3, another multiple choice. What is the correct end behavior for the graph of this polynomial? F of x equals x to the 4th minus 3x cubed minus 6. So again, you can see that I'm writing out some notes to help me make my decision. The first thing I'm looking at is the degree. If it's even, that means that f of x, the ends have to go in the same direction. And then because the leading coefficient is positive, it has to go up in both directions. So right away, as I'm looking at these, I see somewhere it says f of x goes to negative infinity. No, that's not going to happen. They're going up in both directions because it's even in a positive coefficient. Okay, so that's not going to work out. Same thing with this one. That can't work out because it says f of x is going to negative infinity. Another reason why C can't work is because it says as x goes to negative infinity and as x goes to negative infinity. Okay, you should never have x going to the same place. Those should always be opposite. You need to know what happens on the left side and the right side. Okay, again, this says that it's going to negative infinity, not going to work. This says twice, on the left it goes down, on the left it goes down. That's not the end behavior. So it does have to be A. On the left side it goes up, on the right side it goes up. Okay, questions for me on that one? Are you guys feeling good about those? Deciphering the end behavior? Okay. Alright, now for 4, graph on a calculator and estimate the local maxima and minima for each function. So when we've been doing this, we have been estimating those to 3 decimal places, the nearest thousandth place. It'll be the same thing on your test. It will either ask you to round to a certain place, or it might be a multiple choice answer, and it would be rounded for you. Okay, so there are 2 local maxima, 8.026 and 10.940. Okay, the local minima is going to be 6. Okay, let's do
let's just do a quick review of how to find those. Okay, so I already have this plugged into my calculator. Okay, I'm going to graph it. And then just remember, if you ever get a different window, you can always go to Zoom and then 6 for the standard window. And then if that's not enough space, then you can adjust your window. So that's not enough space for me on the top. So, yes. And then it's not enough space for me on the top, so I'm going to have to go to like 20. I like to give myself space so I have room to do the minimum and the maximum. Okay, and then you go to second calc. And then to find the maximum, you're going to do this twice. Okay, so it's asking you left bound, so you can go to the left of that turning point, and then to the right of the turning point, and then try to get right on that local maxima, and then this is where you'll round. Remember, the maxima is the y-coordinate. Okay? So that's where we're getting the 8.026, and then we would do that again for the second one. This time you're just going to go to the left of the second one and to the right, and then try to get right on there. And there you go, the 10.940. For the local minima, you do have to make sure that you choose the correct one. So this one is the minimum, so I'm going to go a couple to the left, couple to the right, try to get it right on there. Okay, and then 0.6, exactly. That just so happens that it's the y-intercept. That doesn't happen all of the time. Okay, so remember we talked about this last week. Okay, you can see on the graph it has how many turning points. Remember, the turning points are the same as the local max and the minima. So there's 1, 2, 3 places where it changes direction. So there's going to be 1, 2, 3 local maxima and minima. Okay, and then for B, the degree is 3, so there should be 2. The local max in that case is 10. The local min was 0.519. Okay, do you guys have questions for me on those? Those are good? Okay. All right, and then I know we did some of this together last week, so we talked about, hey, if this has a degree of 4, there are 3 turning points. So if it has a degree of 4, there are 3 turning points, and that's because the number of turning points should be 1 less than the degree. Okay, so whatever the degree is, the turning points are 1 less than that. Okay, so that might be something you want to write down, or maybe that's something that you already remember. Okay, and then this one actually says this, but in reverse. If there are 4 turning points in the graph, then the polynomial has a degree of what? Explain. Well, the degree would have to be 5 because the degree is 1 more than the number of turning points. Okay, so if you can see the graph and find the turning points, you can figure out what the degree is. And then because the degree is 5, what's something else we would know about this? Yeah, something about the 5. What else would we know is 5? The zeros. What is that called? That the degree is the same as number of zeros? Fundamental theorem of what? Algebra. Okay, great. Okay, all right, let's turn our page over. And, yeah, for number 7, I really should have said to do that without your graphing calculator. That's the whole reason why I wanted you to write an explanation there. So we'll look at that.